Good morning. My name is Kainsan Munoye, and in this video, I'm going to discuss resource management and scheduling. These are topics in computer science, so if you are not computer science but you can still enjoy and understand this concept, this computer related concept. So, what is resource management? Just I give a little overview. A little overview is resources are components of the computer that can be used by processes. Okay, so if you have a user process, you need a resource, you need a disk, you need files, you need the memory. So we have resources. We also have the CPU time. So how do processes use all this resource? So if there is no way to manage this resource, there is going to be chaos and the system might just crash. So how does the operating system manage the resources? And how does the operating system perform scheduling? Now, there is an aspect or a component of the operating system called scheduler. Okay, I remember when I did my Oracle certification, I studied about resource manager in Oracle database, but that's Oracle database. In operating system, we have a scheduler that does this work. So how does a scheduler, okay, schedule processes to run? Because if there are if 100 processes waiting to run, how does the scheduler choose which process to run first, which process to run next? Okay, how does the scheduler make sure that no process is starved of the CPU resource? How does it ensure that no process runs for unduly amount of time, for very large amount of time, while the other process are just waiting for a long time? So that is what we are going to discuss: resource management and scheduling. So just pay attention. You may have to rewind, you may have to pause for you to understand. It's in form of slides, so I'm going to be explaining the slides. Now the scheduler operates using certain criteria. There are five of them. The five criteria the scheduler uses: one is fairness. This means that each process gets a fair share of the CPU time and ensures that no process is denied CPU time. Okay? Ensures that no process is even running for too long a time such that other processes have to wait for too long. Efficiency ensures that the CPU is not kept idle, the CPU is used close to 100% of the time. Response time for interactive users: if you issue a command to the operating system, how long does it take to get your response? Okay, it has to be very short. Turnaround time for bash users who have a certain amount of tasks or processes to execute, how long it takes for them to get all these things done and get a result. Then throughput: number of processes processed or handled in a given time. So let's now look at scheduling algorithms. Okay, so the CPU uses scheduling algorithms to choose which process is going to run next. So I think there are six of them. We have round robin scheduling, priority queue scheduling, multiple queues, policy driven scheduling, shortest job first scheduling, two level scheduling. And so let's start with the first one. I think this one should be the simplest, the round robin scheduling. On here, each process is assigned a time interval called a quantum. So it has this quantum of time to run. If it runs at this within this time, if it runs out of this quantum, the CPU is preempted and the process is moved out of the running queue, or is even blocked, so that another process is run. So in this way is a round robin manner, so all processes one after the other is run in the same amount of time. So let's look at the next one, the priority queue scheduling. Here we have each process assigned a priority, and this is a runnable process. Runnable also means ready. The process with the highest priority is allowed to run, and then the next process with a lower priority, the lower priority onto the lowest priority. But this might be a problem, because what if the process with the higher priority runs for a very long time? Well, the scheduler handles it this way. For each clock pulse, the process that is running, the priority drops. So for each clock pulse, it keeps dropping until it drops below certain minimum, and then a process switch occurs and the next process continues to run. That's about priority queue scheduling. Then we have multiple queues. In case of multiple queues, there are classes, priority classes that are set up. So these classes, each process is assigned to a class, and each class has a priority, right? So processes in the highest class run, okay, for one quantum is amount of time, and the next class, next highest class runs the next highest class, and so on, and it moves down, and that is how multiple queues. So you have multiple classes of multiple queues with priority. Policy-driven scheduling. In policy-driven scheduling, processes are created. A policy is created, and this policy defines the amount of time assigned to each process. So a policy have to be defined. Now, this policy might be defined based on some criteria. For instance, how long have a process been in the ready queue waiting? It may be a policy. The process that waited for the longest time might be allowed to run, or it may take the number of users, logged in users, might also be a criteria. Maybe each user is allotted 1/n of the CPU time, where n is the number of logged on users. So this is policy-driven scheduling. Shortest job first. I think this is very simple. It's a giveaway. The process with the shortest time with the job with the shortest time is allowed to run, but in this case the scheduler have to know the duration in advance for each of the process. Then we have the two-level scheduling. It means that there are two levels of scheduler. Okay, so one of them is responsible for moving the ready processes between the disk, the permanent storage, okay, and the memory, and the next level of scheduling is responsible for moving the process from the ready queue to the running. You understand it? The first one handles swapping. Swapping I'm going to discuss when I discuss memory management, swapping, moving from disk to memory. So we have this other one handles scheduling. So I would like to thank you for viewing. Subscribe to my channel if you have not done so. Leave comments, ask questions, tell me what topics you want me to discuss. And once again, thanks a lot for viewing.